joining our OneAtlas webinar, where we will be showing you different ways to use satellite imagery and transforming data into insights. I'm pleased to hand over the presentation to Jeff and Lisan to introduce themselves and to get started.
Hello and welcome. My name is Lisan Leonetti and I am the OneAtlas Data Product Manager. So OneAtlas is our platform of satellite imagery services, and our vision is to democratize the access to Earth observation data to help any users develop new applications. So today we will talk you through how to transform satellite imagery into insights thanks to machine learning technologies. So Jeff, the floor is yours.
Hello and welcome everyone. So my name is Jeff Faudy. I live in France. I've been working for Airbus Defense and Space for the last 10 years. And I've spent actually the last 5 years focusing specifically on artificial intelligence applied to satellite images. And I'm very excited today to share some of the outcomes of this work with you.
Our world is changing really fast. And today the question is not really how to access data to solve all the challenges that we face, but rather how to turn this data into insight to answer these challenges timely. So probably one of the challenges you see right now is a reason why you're attending this webinar. You have access maybe to tons of data, but that are unexploited, and you want to treat them and turn them into insights. Maybe you want to automate the way you are currently doing analysis within your organization, or maybe leverage the power of artificial intelligence to automate these processes and focus on specific use cases. Or maybe you want to build your own sovereignty over artificial intelligence, but don't want to start from scratch. So this is the type of challenges we are going to uncover today with Jeff.
So I think creating robots and artificial intelligence has always been a dream for computer scientists. Yet it is only with recent improvement in computing power that this objective has become more accessible. And specifically with cloud computing, which provides scalable resources for computing and storage, all in the same location with super fast connections. So in computer vision, we focus mostly on deep learning, which is the most effective technique for image classification and object detection. It's actually deep because there's a large number of layers, so it's a deep learning or algorithm. So in the last 10 years, major players and big company and researchers have invested a lot of time and money in this field, and records have been broken continuously year after year. So enough observation typically build on this. So I will explain you how. This is a typical production chain for a deep learning algorithm. We first buy or craft large training data sets for the type of object that we are looking for. Then we select a deep learning architecture that is well suited for our problem. Usually, we need to adapt it slightly because satellite images are quite different from standard photographs. They're much larger, and at least the objects that need to be detected are small compared to the size of the images. After we've done this, we can train the model on a large data set. This part generally requires a GPU, graphical processing unit, and we do that on the cloud so we can have more resources, but only run them when we need them. Finally, we do a performance measurement according to the metrics that are well suited to our use case and decide if the model should go to production or not. If not, we then need to iterate on the training, the model architecture, or the database itself. And in most cases, the trained dataset is the one that needs the most of our efforts. This is why we need to build a dataset that is very clean, well balanced across classes, well spread all over the world, or at least the region of interest that we're looking for. So if you would like to follow this path and increase your skill in artificial intelligence on satellite images, we would like today to provide you some tools and services to bootstrap your activity. We can provide you with some large curated satellite imagery datasets from OneAtlas that you could use to train your own algorithm. We can also provide you with some state-of-the-art models that will be easy to train on your imagery, so you can actually create your own models. And we can help you setting up the right production environment so you can start improving these baseline models and make them more suited to your own specific needs. So during the rest of the presentation, we will cover the description of these ready-to-use AI datasets and what needs to be done to tune them to your specific use cases, how you can access to fresh imagery from OneAtlas to get fresh results and improve your models, and then we will add some extra information about the training of the staff, the qualification of algorithm, and so on. So let's start with the artificial intelligence datasets themselves. So how do we create them? One of the first data set that we created was for the ship detection challenges that was hosted on Kaggle in 2018. You can still check it on the platform itself. It contains thousands of images with tens of thousands of annotations of ships. We have worked a lot on the data set before the competition, and we also worked a lot on it afterwards when we had to select the best model among the 3 winners. Since then, we have learned to make better and better data sets, and thus better and better models. So I will now present 5 data sets in the following slides. For each of them, we have followed the same methodology. First, we start with a precise description of what we are looking for, and then we select suitable locations worldwide to find these objects. We search for the most valuable images in OneAtlas Living Library on these sites. It has not to be the best images. We also want clouds, snow, fog, low light, and other complication. This is to make our model as robust as possible. We then have human annotators working with artificial intelligence tools so that we can spare human labor and make sure that the data set is as clean and sharp as possible. So the first one is a ship detection. That's been the one we've been working for since a long time, and that's a new version compared to the one on Kaggle. It contains more military ships than the previous version, and also include main categories such as fishing vessels, merchant vessels, and so on. You can train a standard state-of-the-art model over the data set with no fancy development tricks and no super powerful GPUs, and you will get out of the box a detection rate better than 80% and a precision rate over 80%. So the detection rate actually measure the accuracy, and the precision rate actually measure the number of false alarms. So that is pretty much a good model. Okay, so you don't miss too much ships, and you also don't do too much false alarm. The interesting thing is the quality has been measured on a completely different data set. So this is what is important. The quality of the trained data set guarantees that the model will be good enough to correctly predict on new unseen images. So that's really what we've been pushing. So a very good data set that enables you to make a very good model out of the box. Now we got the next data set is on aircraft detection. Okay. So we've been annotating more than 10,000 aircraft worldwide on a large number of military air bases and international airports. We have a number of classes ranking from helicopter, fighter, bomber, small aircraft. And again, the precision rate that we can achieve is over 75%, right from the data set with no fancy development on the model. We can also offer a vehicle detection. So this one has been specifically designed for detecting vehicles. We offer a large number of annotation, detection rate, and precision rate over 70%. Definitely, vehicles are a little bit more difficult to see on Playad images, but the model is still performing good. And we see that you can improve on that. And then 2 other models that have been created on spot images. This one is for petroleum oil storage that could run on any location on the Earth. We also have a large number of annotation, and we provide a detection rate of more than 80%. And finally, one for wind turbine detection. So this one also is working on spot images and contain over 10,000 annotation on wind turbines. It has a detection rate of over 90%, which is quite very good. It serves for the surveillance of electric production, but also air navigation obstacles, because wind turbines are one of the most important obstacles to our navigation. So now that I've presented these 5 data sets, I mean, one of the questions is, why does this really matter? And why would you need to actually access to data set and recreate a model? The thing is that maybe you're not exactly interested in vehicle detection, but maybe you're interested into armored vehicle detection. And the trick is actually that you can use such a model to fine-tune it to your specific use case. If you have a generic aircraft detector, you can easily fine-tune it to become a very good Russian aircraft detector. Or you can actually specialize your vehicle detector to detect armored vehicle in the desert. So instead of using tens of thousands of objects, you only need a few hundred of objects to tune your model. So the model already know about the vehicle, you just need to tune it to your specific use case. So that is where you will gain a lot of time and energy in creating your models. You can start from a model that already knows about the subject you're looking for, and then just fine tune it to your specific use case, and you'll be very fast to do that. And you can do that behind closed doors. You can do that in your own company. You don't need to go online or whatever. You can do that with your imagery, your specific location, your specific object of interest. We can switch now to satellite imagery and base map, and I will leave the floor to Lisa.
Thanks, Jeff. So now that you've seen how to leverage off-the-shelf datasets to get started with model trainings, I will now introduce you to our imagery capabilities that you can leverage whether to create new datasets, specify existing ones, like Jeff just presented to you, or simply obtain timely insights. So OneAtlas data gives you access to a combination of high and very high optical resolution with Spot and Pleiades sensors. They both offer daily revisit capacity, ensuring effective monitoring. So Spot is a 1.5 meter resolution satellite, and it offers high resolution over broad areas. It makes it perfect for application at national or regional scale. Pleiades, on the other side, is a 50 centimeter resolution sensor, and it is the right answer to extract accurate information. But that's not all. In the next months, we will enrich our content capacity with additional sensors. Vision One, which is an optical sensor at 87 centimeter, which will greatly complement Pleiades and Spot capabilities. We will also have TerraSAREX, which can acquire dataset ranging from 25 centimeter to 40 meter resolution, and is completely independent from weather condition because it is a radar sensor. And last but not least, we will have also Pleiades Neo with 30 centimeter resolution, which will offer the most precise resolution and accuracy of the market. And this is much of importance for artificial intelligence use cases. So let's now have a look at what content is actually available in OneAtlas. Our content is available in two different catalog selections. The Living Library, which provides you with an immediate access to curated imagery selection for artificial intelligence application. Then we have also our extended catalog. So this is the heat map you see right now. Much more content, of course, because it contains our entire archive since 2012 for Spot and Pleiades. So we have thousands of new images that are ingested daily in our platform, and they identify our available content over the world. But tomorrow, as we just seen, new sensors will also enrich this content and enhance our coverage and analytics capability. We can now focus on the Living Library capabilities and how it can help you solve your artificial intelligence challenges. So the Living Library provides you with an access to an extensive stack of archive, author-rectified, but also naturally co-registered. It means that these data have a naturally very precise stacking, which makes it perfect to train accurate models or obtain very precise results. As you can see in this example, there is a perfect co-registration of the data, but on top of this, the imagery selection is curated to be ready to use, marginal cloud cover and incidence angle. And that can be, of course, tailored according to your needs. For example, with more or less cloud cover, as we've seen with Jeff, you can also use some data with clouds or fog to make it as robust as possible. But what about the base map now? The base map is a global curated layer made of Spot and Pleiades data as well, but it's a layer that we refresh every year. So it is cloud-free, dehazed, and color balanced. This product is consistent over broad geographic areas, and thus it's perfect to train model over, for example, specific regions or landscape, or get consistent insights over wide areas like a country. So now that you understand well the OneAtlas capabilities and how it can be used for machine learning, we can now focus a bit more on the application. We have three types of application. The first one is to create a dataset, like we've seen, or add imagery to an existing dataset to train for specific objects or landscapes. So for example, if you would be an organization trying to solve the challenges of free parking spots, you could definitely dig into our OneAtlas imagery capabilities to create a dataset of parking spots. Another example, if you wish to specify an existing dataset, like Jeff introduced to you, you could leverage some car dataset. But if your organization is involved in counting cars over Japan, then you could use specific cars object from the area, from the living library or the base map, and thus specify your model. The second use case on the other side is to apply your algorithm, your models that you train beforehand over time series, if you wish to get historical insights, or over fresh satellite images, if you wish on the other side to get fresh insights. You can also apply these models and algorithms over broad areas to get consistent insights. So what are the differences between these two use cases? So for example, you could have a look specifically on the city of New Delhi in India if you wish to count the car population, maybe to derive some information about pollution or urbanization. So you could look into the 10 past years of car population over New Delhi, or simply run the model over the freshest image to get the latest statistics about it. Or if you are more interested in having these statistics over the entire country of India, then the base map would be the appropriate capacity. So these are just examples to illustrate this application. So here are a few illustrations of datasets for object detection that has been created with the living library or the base maps. So you can leverage our imagery capabilities to do the same, to create your own datasets, or as well add new imagery to an existing one, as we mentioned, adapted to specific objects or landscapes. So here, the example that you can see are bridges, power tower, laser pitch, power generator, and laser marina, but so many more examples are available. So now we are going to illustrate how to leverage the living library to get fresh or historical insights by applying detection model over the imagery. So now we are going to go through a little demonstration of how to apply algorithm over fresh imagery. So in this example, we are going to go at the border between Libya and Egypt and compare two different models applied at different times. So let's get started with the first one, which was acquired in 2018. And you can see here the numbers of cars that has been detected with our model here. And so here in this use case, what is interesting is that we can leverage these insights, so dating back to 2018, and we can compare it with another one that was computed for 2019. And as you can see here, there is a huge difference of the numbers of trucks detected. So whether you have defense and security use cases, or business intelligence, or governmental use case here, you can see how you can leverage this type of historical information through times to monitor events thanks to artificial intelligence. Another example here is over the beautiful city of Marrakesh in Morocco. And I'm not sure you're familiar with this, but the Marrakesh city has a Medina. Here you can see the center. And this Medina is not allowed to have cars. So it's a regulation over the country. So here, for example, governments can leverage this type of capabilities, remote sensing, and as well artificial intelligence to see if the regulations are well applied. We are going to illustrate a few OneAtlas customers and partners references that work with us to create their use cases. So we have Orbital Insight, Preligence, Forest Intelligence, Enveritas, and Birdeye as well. So some of these customers are customers and some others are partners or resellers. And they all use our imagery to create their own model and algorithm. I'm going to introduce you to one use case today, which is Enveritas use case. It is quite interesting. They used our living library to train models over small coffee farms in two different countries, Ethiopia and Indonesia. What is interesting about this model is that they used a state-of-the-art model, a baseline model of farm detection, but they trained the model specifically on the architecture of the Ethiopia and Indonesia region, because they have very different architecture. And this model then helped them to detect automatically the smallholder coffee farm, and thus streamline the process of detecting this coffee farm, since they work in the coffee supply chain verification. So this is a great example, I think, because it shows how satellite imagery, basically remote sensing and artificial intelligence, can improve an industry and streamline the use case very easily.
So here are a few other services that we can provide to our clients and partners. So apart from training data sets, we also have qualification data sets. Of course, we keep this qualification data set completely private, but we use them to qualify various algorithms and provide a rating that could be used to compare various services and providers. This is very useful for the algorithm provider, as we provide complete reports and metrics and extensive examples. It is very useful to get such qualification to improve the models. So we've been working on, of course, aircraft, vehicles, ships, buildings, cold storage, changes, and many others. We do have the data sets to perform the qualification of the models. And finally, we also provide online and on-site training so that you can make sure that the whole team is up to date on these new artificial intelligence techniques and methodologies. Each training lasts for 3 days and is organized as a small AI project. It features some theoretical information, but mainly focus on a lot of practical exercise and coding.
Thanks, Jeff. So now we are going to conclude this presentation and demonstrate how these capabilities can help you solve these challenges. So first of all, you can access off-the-shelf curated datasets and artificial intelligence-ready imagery all at the same place through OneAtlas. Of course, you will save money by collecting only the data that you need for your specific use case, as we've seen, whether just adding additional imagery to specify a dataset or selecting exactly what you need. You will also save time by using off-the-shelf dataset, of course, and the curated imagery selection. And lastly, you can benefit from our standards, interoperability, and qualification. So we have some nice evolution coming up. As you're probably aware, we will launch the Pleiades Neo constellation this year. It's coming very soon. And we will also have some Sentinel capabilities interoperable with our analytics capabilities. So in the next days, you will receive an onboarding email and ways to get started. So you will first receive the dataset. So this is a surprise. Stay tuned to know more about it. You will also receive some links to get started with a free trial if you wish to have a trial of OneAtlas, but also case studies, and you can get in touch with us with our customer services contacts. So thank you. It was a pleasure to present this webinar. So now Jeff and I are available for a short Q&A.
Thanks to Jeff and Lisan for the presentation and demos. We do have a couple of questions that we wanted to answer before ending the presentation. So the first question is more of a thought leadership question for Jeff. Jeff, where do you see that AI and machine learning is going in the future with regards to satellite imagery?
Well, that's a good question. Well, I don't know where it's going globally, but I will tell you the two topics that we are looking into with a lot of interest currently. There is one point about the quantity of labeled data that we need to make good models. Can we achieve similar performances with less training data and potentially none? This is what we call frugal learning, and it's a fast evolving field. Facebook AI presented recently some results where they achieved good performance on unsupervised training on ImageNet. This is definitely inspiring for satellite images, where we often are looking for a needle in a haystack without knowing in advance the shape and the size of the needle. So this is linked to the capacity to make prediction without any priors on the type of event or object that we're looking for. The second point that we're also looking into is active learning. How can we create AI that gets better and better every time it is used on new imagery? It is maybe less of a scientific challenge, but more of an engineering challenge. We want that our AI is able to criticize itself, deliver reliable confidence, metrics, and amend itself automatically. The theoretical solutions to this problem are already there, but implementing them in production is still to be done. This is definitely something that needs to be in the future of AI for observation in order to make full, usable, and acceptable solution.
Thanks, Jeff. So the second question is for Lisan. Lisan, can you tell us a little bit about the archive coverage that OneAtlas includes if someone is interested in using Airbus imagery for their machine learning applications? How can they get started, and how can they acquire new imagery for their project?
Hello. So yeah, it's really easy to get started. The first thing you can do, and we will send you an onboarding email, as mentioned, to get started, is to subscribe to a free trial. So this will allow you to access our catalog, so you will see exactly what content is available and if it does match with your needs. So yeah, you can discover this content pretty easily. But if you need additional imagery over your area of interest, then you can definitely use tasking services. So place new collection at the time you need over the area of your choice. So you can contact our customer services if you wish to know more about the prices or imagery availability. And as mentioned, you will receive all the information to get started.
Okay, thanks, Lisan. So one more question for Jeff. What are some of the tools that you would recommend to create data sets using Airbus imagery? And what are some of the tools that you would use for applying the algorithms over that satellite imagery?
Well, actually, the good thing is that Earth observation AI model can work with small JPEG extract of satellite images. So we can use very standard annotation tools. And there is plenty of such tools, either free or for a fee, either local or on the cloud. There are also plenty of options to train your own models online. RoboFlow, Gradient, Chicago are being some examples. And of course, you can also implement everything locally behind your firewalls if you need so. For applying models to the imagery, we advocate for the use of containers, also known as Dockers. We have issued an open interface specification, which is available on GitHub, and which decouples the algorithm from the platform. This enables to test multiple algorithms on the same platform, or test the same platform with multiple algorithms, either local or online. This has been very useful for us, and I guess it will also be very useful for other organizations.
Great, thanks, Jeff. So thanks again to Jeff and Lisan for their time. We encourage you to reach out if you have any questions and to sign up for the free trial of OneAtlas to try our imagery and additional services. Thank you for watching and have a great day.